regression, let's look at some real-life scenario. Logistic regression is used in weather forecast and in cancer prediction. Logistic regression is used to predict a categorical outcome that is 1 or 0, yes or no, true or false. For weather forecast, the binary dependent variables indicating the occurrence of sun, cloud, storm, and rain are separately regressed against a series of independent model variables that define a number of weather properties. The data from each of the regression models is collected and matched in order to come to a conclusion that the weather will be sunny, stormy, cloudy, or rainy. Cancer prediction. In this case, the outcome of logistic regression will either be malignant, that means cancerous, or benign, that means non-cancerous. Let's look at the logistic regression equation that is derived from the straight line equation. So, the equation for straight line is given as y equals bx1 plus cx2 plus d. When we deduce the logistic regression equation from straight line equation, y value becomes fixed between 0 and 1. Transform the straight line equation to get the range, y over 1 minus y. So you can see in the transformed equation, now the range is between 0 to infinity. Transform the equation further by finding out the logarithm of the equation, and you finally get a range from infinity to infinity. So, the final obtained equation is the equation for logistic regression. Sigmoid probability. What is sigmoid function? The probability in the logistic regression is represented by the sigmoid function, which is also called logistic function or the S-curve. The equation for sigmoid function is shown here, where t represents data values multiplied by number of hours studied, and st represents the probability of passing the exam. The sigmoid function gives an S-shaped curve. That is, y can either be 0 or 1. 0 as x approaches to negative infinity, 1 as x approaches to positive infinity. In most of the cases, sigmoid function refers to the special case of the logistic function. What is sigmoid probability? The probability distribution output y is restricted to 1 or 0. This is called sigmoid probability. If sigmoid probability theta tx is greater than 0.5, set y equals 1, else set y equals 0. Other than linear regression and its normal equation solution, there is no other closed-form solution for finding optimal weights of logistic regression. Instead, you must solve this with maximum likelihood estimation. That is, a probability model to detect maximum likelihood of something happening. Consider the first example, which we took for logistic regression. To apply sigmoid property, you need to find out the threshold value, which indicates that something more than that value will get rounded off to the higher end value, and something less than the threshold value will get rounded off to the lower end value. In this case, if the probability is greater than 0.50, value will get rounded off to 1. This indicates that the student will pass the exam. And if the probability is less than 0.50, the value will get rounded off to 0, which indicates that the student will fail in the exam. Accuracy matrix. Let's learn what an accuracy matrix is. The accuracy matrix provides you with a summary of the prediction being made accurately. A matrix of confusion is a breakdown of the results of prediction on a problem of classification. The amount of right and wrong predictions is summarized and broken down by each class with count values. This is the key to the matrix confusion. The confusion matrix demonstrates how your model of classification is confused when it makes projections. It provides you insight only into your classifier's errors, but more importantly, the kinds of errors being made. Accuracy matrix includes ROC curve, receiver operating characteristics curve, and UAC, area under the ROC curve. AOC-ROC curve is a performance measurement for classification problem at numerous thresholds settings. ROC is a probability curve, and AOC represents degree or measure of separability. It tells how much the model is capable of differentiating between classes. The higher the AUC, the better the model is at predicting zeros as zeros and ones as ones. ROC curve compares the model's true positive and false positive rates to the ones from a random assignment. AUC, area under the ROC curve, measures the entire two-dimensional area under the entire ROC curve.